Hello world. So today I'll be talking about how you can implement gradient descent with Tensorflow. So this video is meant to help you get started with Tensorflow, or just it will give you a basic idea of basic structure of how you have to make your programs on Tensorflow. And first of all, what we are going to do is we are going to see a sample problem, and then we are going to create a parameter which we are trying to optimize. Then we are going to construct a cost function, then we are going to minimize it with gradient descent. You can use any optimizers such as RMS prop, Adam, momentum for that matter. So we'll be using gradient descent since it's very easy to use and it will help you get visualize much better. So this is the sample problem which we are going to see today. So this is our cost function, w square minus 10 times w plus 25. So if you see over here, it's nothing, just an expanded version of w minus 5 whole square. So this is a cost function which we are going to minimize today. So here I am running Python on Jupyter notebook, and so first of all let me just say to define a parameter, okay, I'll be giving you a basic introduction. So what you need to do is you need to create, first of all you need to import numpy, and it's quite idiomatic to import TensorFlow as TF, since everywhere you see you're going to see notations like this only. So it takes some time since the libraries so to define a parameter, what we need to do is we need to create a TensorFlow variable. So tf.variable dtype equals tf.float 32. So this is a parameter we are trying to optimize, right? And then we need to write an expression for cost function. So from our example, our cost function was w square minus 10 times w plus 25. So we have to write tf dot add w square. So tf dot add is what it's gonna do is w square minus 10 times w plus 25. So tf dot add is gonna add the two parameters which we are passing into it, and then since 10 times 10 and w are multiplied with each other, so we are gonna use tf dot multiply and then 25. So here we have written expression of cost function. So after we write the cost function, then we specify the optimizer which we are going to use and what we are going to do with the cost function. So train is equal to tf dot train dot gradient descent optimizer. So note that here we are specifying the learning rate, so don't set the learning rate too high, otherwise it may overshoot and may never converge at the optimum, or don't set it to be too low, otherwise it would take a lot of time to converge at the minimum. 0.01 is the standard value. So here you can see how much time is it taking to minimize your cost function, and you can then adjust it accordingly. So here we are specifying that we are going to use we are going to train, and then we are going to use this optimizer. Here we are specifying the learning rate, and then we are specifying we want to minimize the cost function, right? And then note that instead of using this expression over here, you can use also this expression also. I'm going to comment it out, but you can also use this also. This is gonna seem simpler to you. So what it does, it overloads the operation, so you can use this also. And then we are going to create an initializer. So in it, so these lines are quite idiomatic and you have to use every time. So after you have created your initializer in TensorFlow, you need to create a session in order to compute this computation graph. So session is equal to tf dot session. In many places you are often going to see with tf dot session as session. So don't worry, these two things are doing the same things over here. And after you create this, you need to run. And then print session dot run w. So note that we are not actually doing anything, so it's going to print out 0 only because we haven't done anything yet. So we need to first run session dot run train, right? After that we need to we have run a session once, okay, so it's going to print 0.1. so after running this train model for once, it has computed value 0.1. so let's see what value does it print after we run it for 100,000 times. So as you can see, it has printed the value 5. So even if you evaluate this, w square minus 10 times w plus 25, it's nothing but w minus 5 raised to the power 2. So obviously the answer would be close to 5 only. So it's computed the right thing. So if I draw the contour over here, so what it does is, when we ran it for like one iteration, it was not even close. It was not even close to our global optimum over here. So when we ran it for 1000 iterations, what it does, it like tries to come close and close to this global optimum, and then after it comes close, what gradient descent is gonna do is it's gonna converge near this global optimum, and as a result we got the value 4.99. it's not close, it's very close to 5 but not exactly. So this is what gradient descent is gonna do. And if you're gonna use other optimizers like RMS prop, so this vertical oscillation over here, it's gonna be lesser than gradient descent, so it will help you train your neural network much faster, because we want learning to be very slow in vertical direction. We don't want it to be much large. So I hope you get a better intuition of how you can get started with TensorFlow programs and how you can use the optimizers and minimize the cost function. Know that I'll be adding much more videos regarding neural networks also. with TensorFlow. We talked about Keras a lot, and I thought maybe you wanted some help regarding TensorFlow. If you found this video to be helpful, please subscribe to my channel and stay tuned for more deep learning videos. Thank you. Talk to you guys in the next one.